Have you ever had a hunch, a thought like, does this coffee actually make me smarter, or does it just feel that way? Well, how do we get from that simple question to a solid scientific fact? That's the journey we're going to take, from a simple idea to proven science. Let's dive in.
So let's stick with that one. Does coffee really improve your memory? It's a perfect starting point because pretty much everyone has an opinion on it, right? You down a cup of joe, you feel sharper, more on the ball. But is that feeling real? Can we measure it? That question right there, that's where all science begins.
Look, we all have these little theories that help us get through the day. But the huge challenge for psychology is taking that personal hunch and turning it into something everyone can agree on, a provable fact. And that whole process, that very first spark of an idea, researchers call that the context of discovery.
And that brings us to our first step. It all starts with a question. This is what we call the context of discovery. Honestly, this is the fun part. It's where creativity and curiosity take over, where just noticing something about the world can kick off a whole new area of research. So what this really means is, this is the starting line. It's that moment where a researcher just looks at the world and goes, I wonder if these two things are connected. For our little experiment, it's that simple thought. Coffee seems to make me feel sharper. It's a great place to start, for sure, but it is absolutely not where the story ends. And why isn't it the end? Because the second you have an idea, you run smack into a massive roadblock, your own human brain. Our personal observations are, to be blunt, kind of terrible and unreliable. And if we're not super careful, they can send us chasing completely wrong answers. This slide just lays it all out, doesn't it? On one side, you've got our everyday observations. They're personal, they're subjective, they're messy. And on the other side, you have the scientific method, which is designed from the ground up to be the total opposite. It's objective, it's skeptical, and it's got all these safeguards to protect us from, well, ourselves. So one of the biggest troublemakers is something called observer bias. Think of it like this. Your beliefs create a filter. If you believe coffee makes you smarter, you're way more likely to notice and remember the A+ you got on a test after a latte, and you'll probably forget all about the time you bombed a quiz after a double espresso. And hey, this isn't just a problem for us regular folks. Scientists have to worry about it too. That's called expectancy bias. A researcher who really wants coffee to boost memory might accidentally treat the coffee drinkers a little differently, or interpret a fuzzy result in their favor without even realizing it. And then there's the big one, the incredible mind-bending placebo effect. This is where your own belief is so powerful, it can create a real result. Seriously, you can give someone a totally fake pill, tell them it's a miracle memory drug, and their brain can actually cause a real, measurable improvement, just because they expected it to work. How wild is that? Okay, so with all these biases trying to trick us, how do we ever find out the truth? Well, this is where our hero enters the story. It's called the context of justification. You can just think of it as the official rulebook scientists follow to run a fair test, a test that dodges all those biases to give us an answer we didn't actually trust. So the very first rule in the book is you have to get specific. You can't just ask a fuzzy question. You have to turn it into a sharp, clear, testable statement called a hypothesis. So does coffee help memory? Becomes something like, people who drink caffeinated coffee will get higher scores on a memory test. See? Now that's something we can actually prove or disprove. Next, we've got to label our players. The independent variable. That's the thing the researcher is changing on purpose. It's the potential cause. In our experiment, it's super simple. It's the coffee. We're the ones deciding who gets the real stuff. And if the coffee is the cause, then the effect we're looking for is the dependent variable. Its outcome depends on what we did with the coffee. And for us, that's the score on the memory test. We're waiting to see if the coffee actually causes a change in that score. All right, we've got our razor-sharp hypothesis, we know our variables. It is time for the main event, the classic scientific showdown, the experiment. This is, hands down, the best tool we have to figure out if one thing truly causes another. Now, the secret sauce to a good experiment is comparison. You need at least two teams. The experimental group gets the real deal. They drink the actual caffeinated coffee. But, and this is so important, you also need a control group. They get what they think is coffee, maybe a decaf that tastes the same, but it's a placebo. That way, we can see if the caffeine is what's making the difference and not just the act of drinking warm coffee. So how do we decide who gets the real coffee? You can't just ask for volunteers. The decision has to be totally, completely random. This is called random assignment, and it is maybe the most important step of all. By flipping a coin for every person, we make sure that other things, like natural memory ability or how much sleep they got, are all mixed up and balanced out between the two groups. It makes the coffee the only real difference.
So let's put it all together. You can see the whole game plan right here. Step 1, you randomly assign people to a group. Step 2, you give one group the real coffee, the other the placebo. Step 3, everybody takes the same memory test. And finally, step 4, you compare the average scores. If the coffee group did way better, well, we can be pretty darn sure it was the caffeine that did it.
Now, figuring out our coffee question is cool and all, but this whole careful, methodical process, it's really about something so much bigger. It's about building a real, deep understanding of why we do the things we do.
Because look, this process serves these much bigger goals. Psychologists first want to simply describe a behavior. Then they want to explain why it happens. From there, they try to predict when it'll happen again. And sometimes they can even learn to control or change that behavior for the better. But all of that, every single step, is all in service of that final goal, to improve the quality of human life. And that's really the magic of it, isn't it? What starts as a simple, everyday hunch about a cup of coffee gets transformed into solid knowledge. It's this process that separates a random opinion from a scientific fact, and it gives us real tools we can use to make life better for all of us. So the next time you're scrolling and you see a headline that says, "New study proves X," you're now ready to think like a scientist. Instead of just taking it at face value, what's going to be your first question? Maybe you'll wonder, yeah, but did they have a control group? Or how did they make sure it wasn't just the placebo effect? Asking those questions, that's the first step to really understanding the world. Thanks for tuning in.